Welcome to another session of Decision Science for Operations Management. Today we are going to do together the fourth topic of network models in chapter 6. So far we have done three sections: supply chain models, that included supply chain models, transportation models and transshipment models. The second one was assignment problems, and the last one we did together was shortest route problem, that was that GPS challenge. Today we are going to do maximal flow problem. Maximal flow problem first is categorized in chapter 6 as distribution and network models. So many of the things that we have mentioned and discussed regarding the network models apply to maximal flow problem. All and also it is very similar to shortest route problem. The most famous example of maximal flow problem is a traffic problem. Have you ever thought about this question, that what is the maximum capacity of all the roads that we have between, for example, Birmingham and Montevallo? What is the maximum capacity of cars over there? When we talk about the capacity, let me give you an example here. Imagine here we have a highway that it is like this. Okay, this is, imagine, is a highway of 100 miles, and the capacity of this highway here, when the highway is wide, is x, and when the highway is narrow is x3. Okay, if I ask you what is the capacity of highway here between, in fact, the capacity of highway in the wide area, what is the capacity? Okay, you may you would say x. Okay, what is the capacity of highway in the narrow part? Okay, it would be 1/3 of the wider one. Makes sense. But if I ask you what is the capacity of all highway, including wide and narrow parts, what would be the capacity? The capacity would be x over 3. Because although you can pass the traffic with the speed of x, but as soon as the traffic gets to this point, the speed would be x over 3. And this part will determine the total capacity of the highway. In fact, it is very similar to a chain, that we say, what is the strength of chain? The strength of chain equals to minimum of this link. In fact, the strength of a chain equals the weakest link. For example, if the weakest link is this, the strength of the chain is determined, is defined, is specified by this link here. This is exactly the case regarding roads. When you have many roads that are connected to each other, the capacity of these roads between the beginning and end is determined, is it's specified by the road with the least capacity. Exactly. remember this example. It is exactly the same as this example, because when we talk about chain and we say the strength of a chain is the same as the strength of the weakest link, it makes sense. And it is exactly the same thing with the roads. So when they want to, for example, in a municipality, to talk about the capacity of traffic that can go from 1 to 7, it is not just easy question that you can say, for example, go for the maximum, go for the minimum, or go for the summation. No, it is not like that. For example, if the only way is, for example, if we focus on the road 1, 2, 1, 2, 5, 7. Okay, 1, 2 has the capacity of 5,000 cars per hour. 2, 5 has the capacity of 3,000 cars per hour, and 5, 7 has the capacity of 8,000 cars per hour, or vehicles per hour. What is the capacity of 1, 2, 5, 7? It is the minimum of them. It is 3,000. Because no problem. It doesn't matter that here you have the capacity of 5,000. They are gonna create a queue here because the capacity here is 3. It doesn't matter that the capacity of 5.7 is 8,000, because after 2.5 the cars will get into 5.7 with the capacity of 3,000. So this highway, this road would be a slow one. This would be very slow. This would be busy, because here we sorry, when I say about busy, I mean beginning of this road, because all the cars that enter 1, 2, they enter this road, and it is the capacity 5,000. But here they would stop to form a queue because the capacity here is 3,000. Okay, so here we have Cincinnati North, that is the entering point, and Cincinnati South, that is the leaving point. For example, the municipality in the Cincinnati wants to know what is the maximum capacity of the roads that connect 1 to 7. You may ask, what is the use of this? Imagine there is also another road, and it's a major road that I just drew it. This one, let me make it more stood out. Okay, and let's say it has a major capacity of 10,000 cars, and for some sort of construction they have to close this main road that has the maximum capacity. They want to see if the remaining roads in the city can satisfy the demand. That's a logical question. So they must have an approximation, they must have an estimation of the flow load of cars between 1 and 7. So they come here and calculate the flow capacity between 1 and 7. Let me show you here. So you see they come and calculate the capacity between 1 and 7, and they see if still they can satisfy the demand. So we can categorize this application that we are going to do, this case that we are going to do, as a traffic application. And again, like the shortest route problem, you will find it fascinating in terms of capability in giving correct answer, and it tells how you can satisfy the demand with specifying exactly which roads must be taken. Okay, so with this introduction, now you should be fine when we start checking maximal flow problems. The objective in a maximal flow problem is to determine the maximum amount of flow vehicle messages. And as I told you, the most famous example of this type of models are vehicles, traffic ones, but you can go for fluid, you can go for with messages, you can go with electricity networks and all those things, because you want to make sure the infrastructure you have available can meet the demand that can enter and exit a network system in a given period of time. In this problem, we attempt to transmit flow through all arcs of the network as efficiently as possible. And what will happen in this situation? Of course, you will come to some situation that you are gonna say some of the roads are of no value, some of the arcs are of no value, some of the links are not needed to be closed. And when we want to talk about this, about electricity network, it is in fact, you say that, okay, turn off that part of the grid. We don't need that. We have a demand. We need to flow all this electricity between all these roads, through all these grids, and some of them must be turned on and some of them must be turned off. When we solve this problem, you are gonna get the point much better. Okay, the amount of flow is limited due to capacity restriction on the various arcs of the network. If it is a road, the capacity is limited. If it is a fluid, the capacity is limited. If it is electricity, the capacity is limited. We just want to make sure what is the maximum amount of electricity or traffic we can push through this network. For example, highway types limit vehicle flow in a transportation system, while pipe size limits oil flow in an oil distribution system. It explains it very well. As you can see, it says highway types limit vehicle flow and pipe size limit oil flow in oil distribution system. The maximum or upper limit on the flow in an arc is referred to as the flow capacity. So when we find the maximum possible flow that is possible to push into the network, it is the flow capacity. So in fact, when we are doing this type of models, we are trying to find the maximum capacity of a network, a very practical type of models in many different areas. Even though we do not specify capacities for the nodes, we do assume that the flow out of a node is equal to the flow into the node. Just let me give you a hint about this. See, sometimes in real world, when electricity is passing a node, some of it may be lost. But in highways, never such a thing happens. Of course, when you are considering an intersection and traffic goes inside that intersection, the traffic goes inside and the traffic getting out of that intersection are the same. And so it is the major assumption of the maximal flow problem that we are doing together, and we assume that there is no waste in going into and out of a node. Everything that gets into a node will get out of the node successfully.